Hello everyone. Today I am going to explain the last problem of Leetcode Weekly contest 445, which is count numbers with non-decreasing digits. So what is the problem? We have given two integers L and R represented as string. Now we have to find the count of integers in the inclusive range L to R whose digits are in non-decreasing order when represented in base B. So let's take one example. L23, R28. Let's take the second example. 2, 7 and B equals to 2. So L is 2, R is 7 and base equals to 2. So if we represent 2 in base 2 format, then it will be 1 0, and if we represent 7 in base 2 format, it will be 1 1 1. So let's write all the numbers from 1 to 7 in base 2 format. Okay, the first one will be 1, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7, right? Now we have to find the number of integers between 2 and 7. So from 2 to 7, whose digits are in non-decreasing order. So here you can see that digits are in decreasing order, right? So this is not possible because this is not a good number. You can say 1 1, the digits are in non-decreasing order. So this is a good value. 100, this is digits are in decreasing order. So this is not possible. Same for 101. Same for this, and this is 111, the digits are in non-decreasing order, so this is possible. So the answer will be 2. Okay, only 3 and 7 are good integers, you can say. So the answer will be 2 here. Okay, now the problem, before discussing uh, the problem generally divides into two parts. One is like how we can change one integer to a base, a different base, and the second part is to calculate the count. Okay, so here you can see if we look at the constants, the brute force solution I am not going to discuss. You can iterate from L to R and take the count. That is the brute force solution. I am not going to take time in that. Now here you can see that L dot length and R dot length is 100. Okay, L dot length and R dot length is 100. Now if the number is in the range of 10 to the power 18, okay, in the range 10 to the power 18, you know about how we convert a number to a different base. Let's say we are converting a number from base 10 to base 2. So let's say the number is, let's say, 7. Okay, so what we do, if we divide it by 2. Okay, first if we take divided by 2, then we get 6 and we get remainder of 1 and the quotient is 3. We again divide 3 by 2. Okay, 3 by 2, then we get remainder as 1 and quotient as 1. So we get 1 from here, 1 from here, and 1 from here. So the answer will be 1 1 1. I hope you get it. So let's take another example. I will this is quite straightforward and well known to you, but also again I am going to explain this. Let's divide 10. Okay, so if we divide 10 by 2, then we'll get quotient as 5 and this as 10. Okay, 0. Now if we divide 5 by 2, then we will get quotient as 2 and this remainder as 1. Now if we divide again 2 by 2, then we will get quotient as 1 and remainder as 0. Okay, then our value is becoming, I think, 10. If we represent it in base 2 format, it will be 8 1 0 1 0. Okay, so we have to take 1 0 1 and 0. That is the way we change a number to a base 2 format or different base format. We divide them repeatedly. We divide them repeatedly, and we get the quotient and then divide the quotient again. Okay, that is the way we change a number to a base, a different base. Okay, we divide them by that base value. Okay, now here you can see that the number is represented as a string, so we can't really do our normal division. We have to do kind of a string division. Okay, so how we are going to do the string division, that is important to us. So let me discuss that how we are changing one value, a specific integer value, from a base 10 value to a base different base value. Then I am going to explain the next part. Okay, so let me take some time. Okay, so let's discuss how we'll change the value to a different value. Okay, So let's say we have something like, let's explain now. Let's say 12. Okay, let's explain 1 2 3 4. Okay, 1 2 3 4, and we try to change it to a base 16 format. Okay, base 16 format. Okay, then what we do, let's say it is represented as a string. Okay, so we want to divide 1 2 3 4 with 16. Okay, now how we are going to solve this? Okay, so initially we will iterate from left. Okay, now we have 1, first digit as 1. Is 1 greater than 16? No, right? Then we move to next digit 2. Okay, so now our character becomes our value becomes 12. Is 12 greater than or equals to 16? No. Then we come to 3. Is 123 divisible by 16? Okay, 123 divisible by 16? Yes, 123 is divisible by 16. Okay, 16, I think 16 into 8 will be 16 into 7 will be 102. Yeah, 112. 16 into 7 will be 70, and 112. So if we divide this by 112, we'll get 11 as a remainder. So we'll get 7 and 112. Okay, now again after that we'll have 114. Okay, so we have the new value as new carry as 11, and we are taking 4 from up to down. Okay, now again we'll take 7 and we'll get 112 again. Okay, 112. Then our now the carry becomes 2. The after in the remainder becomes 2, and our quotient becomes 77. Okay, for 77 again we'll check that if it is the first digit is divisible by 16 or not. No, then we add the another 7. Okay, 77 is greater than 16, so we take 16 into 4 is 64. Okay, 64, so you get 13 as the quotient. Okay, sorry, 13 as a remainder, and 4 as a quotient. Okay, so our answer will become our will come from I think that it should be like 2 13 and 4. Okay, 2 13 and 4 will be our value. That will be our value. I am not sure the order. I think it could be reversed also. I don't want to think that. You can think that we'll take 2 first, and then we will take 13, and then we will take 4. Okay, that's how we will uh, pass, like will represent the value of 1 2 3 4 in base 16 format. So I'll now explain the code how we are changing a specific string is from base 10 to a different base b. Okay, so this is the convert function which takes a string as the input and a base as the input, and it changes the value to a different base. So str is greater than, always greater than 0, so this is not important. Now this is our result, and our number is str. So we are checking while number is not equals to 0. Okay, now our initial carry is 0, so carry will take us this value. Okay, initially the carry is 0. After the first digit the carry will be 1. After the second digit the carry will be 12, and after the third digit the carry is 123, and then we will divide it by 7. Then after that our carry will again be 11. Okay, that's how we are going to approach it. Okay, so we are iterating over character in the from left to right in the number. Now our digit is current character minus 0. Now our current value will be carry into 10 plus digit. So initially carry is 0, so carry into 10 plus 1 will be 1. After the second iteration, the carry into 10, 1 into 10 plus 2 will be 12. So the new number will be 12. Right, current value will be 12. The quotient will be current value by base. Okay, current value by base, and carry is current value modulo base. Now if the quotient is not 0, so initially if we divide 1 by 16, the quotient will be 0, right? Quotient will be 0, then we ignore that. Okay, so if the number is empty and quotient is 0, not 0, if the number is empty and quotient is 0, this case we are ignoring it. Otherwise we are adding the new number as quotient. So new number is defining by quotient. New number after that will be 77. Okay, so a new number plus equals to quotient plus 0. Okay, and at the end, after the entire division part is done, our remainder will be 2, and that will be added to our number. Okay, so 2 will be added to our number. This is the first iteration is done. Now if new number is empty, then we are appending it is 0. Okay, if new number is empty, then we are appending 0. This will I don't think this will be a case, but I have added it. Okay, so this part, our number now becomes 77, and our answer becomes 2. After dividing again, we'll get 13 as remainder. We'll add 13, right? And our new number will be 4, and after the end we'll get 2 13 4, and at the end we'll reverse the result. Okay, we'll reverse the result. So our final answer will be 4 13 2. If we represent it in hexadecimal format, it will be like A B C D. So 4D2. Okay, 4D2. If we represent 1 2 3 4 in base 16 format, it will be 4D2. Okay, I hope you get it. How we are converting a base 10 number to a base 10 string to a different base. Okay, in a string format. So this is the convert function. Now this part is very important. I have explained how we are changing it. This is a major part of the problem. Now comes the second interesting part, how we are counting it. So for counting it, we will be using some approach which is called digit DP. Okay, let me increase the size. Okay. Mm, let me increase the size. Mm, okay. Now let's take another color and let me try to explain the digit DP part. Okay. So how we are using the digit DP here. Okay. Digit DP means that we will iterate over the digits. This digit DP part is simpler than the changing the problem into changing the base of a number from a base 10 to a different base. Okay. So initially, let's say we are at base 0. Okay, we are at base 0, right? So our number is uh, 0. Okay, now this is the first parameter, which is index of our recursion state. Okay, our recursion state first parameter is index, right? Now we will fix the length of the string. Okay, fix the length of the number. Okay, let's call it length. Index length is our next parameter. Okay, now the next parameter is our last digit. Okay, I will explain why I am taking this. Last digit will be our next parameter. So let's take only these three parameters and try to build the number. Okay, now for index 0, we can take any number from 1 to base minus 1, right? 1 to base minus 1, we can take any number. Okay, now we will assume that our last taken digit is 0, so we can take any value from 1 to base minus 1. Let's say we have taken 3 as our first digit. Okay, we have taken 3 as our first digit. Now we move to index plus 1, or initially index was 0. Let's say length was initially state was, let's say, index 0, length let's say 3, and a large digit 0. Now after, let's say, we have taken 3 as the first digit, our index will become now 1. We have moved to the next index. Our length will be same. Length will be same, 1 3, and but last taken digit will be 3. Now in the second character, we can't really take any character from 0 to 2, because our value should be non-decreasing. So we have to take any value from 3 to base minus 1. Okay, we have to take any value from 3 to base minus 1. That is the case why we are taking last digit as our parameter. Okay, last digit as our parameter. Now our recursion function, let's say our recursion function, let's say count, it will take some parameters. One is, let's say, index, I have already explained. Second one, let's say, length, and the third one, let's say, last digit. Okay, and it will also take the string such that the count function will give us all the good numbers. Good numbers means that whose digits are non-decreasing. Okay, so from 1 to, let's say, string s, or let's say let's call it 1 to n, it will give us the count of all good numbers. Okay, from 1 to n, it will give us count of all good numbers. So we will pass in as a parameter. Okay, we will pass in as a parameter. Okay, so count function will take four parameters, I, L, LD, and n, and it will give us the answer. Okay, so at the end, if we check count of r and minus, for any digit DB problem, we use this formula, that we find all the numbers from 1 to r, then we subtract all the numbers from 1 to n minus 1, then we get our desired answer. So we will do this in our recursion state. We will find all the good numbers from 1 to r, and we will again find all the good numbers from 1 to n minus 1, and then we take the difference of that, then that will be our answer. Okay, I hope you get it. Now I'll explain the code. In the code, I'll that will be better. I have taken another extra parameters. I will explain that in the code also. Okay. Now let's jump into the recursion part. So initially, recursion has our four states. One is I. The next one is length. I mean index. Next one is length. Third one is last digit, and this flag is for strict or not. Okay. So I have explained in my previous DB videos also that we take one flag which is strict or not. Okay, so what does this strict flag means? Okay, let's say we have tried to build 1 2 3 4. Okay, now let's say we have taken 1 and 2 as the first two digits. So in the third digit we can take any value from 1 to 3, 0 to 3, right? 0 to 3. Now let's say instead of taking the first two digits as 1 and 2, let's say we have taken the first two digits as 1 and 1. Then in the third digit we can take any value from 0 to 9, right? So this flag means strict or not. Strict means that we can take till si. Okay, si is 3, so we can, this is strict. In this case the flag is 1, so this is strict, so we can take only till value of si 3. But in this case, in the second case, the flag value is 0, so we can take any value from 0 to 9 as our next digit. Okay, so this is the flag. Okay, and we are passing r and b as parameter. Okay, uh, I don't know why I have passed b as parameter. I don't think it is necessary also. So I have passed b to determine the n digit. Okay, here I am determining the n digit as b minus 1, because we are considering here the base as 10. We have taken 10 as the last digit, 9 as the last digit, b minus 1. But if our base is 8, then our last digit will be 7. Okay, so if I is L, this is the base case, then we just return 1. Now this part is memorization. If the state already exists, we will return the value of the state. Now our start value will be, if I equals to 0, we can't take 0, right? If I equals to 0, then we can't take 0. So in that case, the value will be 1. Starting, we will take value of 1, maximum value of 1, and the last taken digit. Okay, that will be our start value, and our n value will be uh, si or ni in case the flag is 1. Otherwise the value will be base minus 1. Okay, that's why we have determined the start and end value. Okay, now our new flag will be flag, and if j less than ri minus 0, that means that we are taking any value less than 3 in the third digit. If the flag is strict, then our new flag will become 0. Okay, then we are doing answer equals to answer plus regression of I plus 1. L will remain same, j will be our next last digit, and new n flag will be our new flag. Okay, the rest of the parameters remain same. Now here the main part of the code, I am converting lb left in lb format. Okay, and rb as base b format. Okay, of r. Okay, lb and rb. Now this part is for initialization. We are marking the entire state of the dp as -1. Now initially r answer will be 0. We will iterate over all the possible values of the length of the string, and we are doing r answer equals to r answer plus, for that specific length we are calculating the value. Okay, similarly for L, we are finding the possible values. Now here comes one interesting part. I have previously explained that we will find count r minus count of L minus 1. This is the possible case. You can do that. You can try to subtract 1 from L, but I have not. That will be difficult because we are dealing with strings, so we have to take subtract 1 from a string, then we have to write another function. Okay, so I don't want to do that. So what I am doing is that I am doing count of r minus count of L. Now if count of r minus count of L, so this will also ignore the value. If L is a good number, it will ignore. So we'll check that if L is a good number, then we'll add that to the answer. Okay, so count of r and count of L I have already explained. Now initially flag will be 1, that means our L is a good digit. Okay, L is a good digit. Now if the current index of the left, okay, left is less than the previous index of the left, then uh, this is not a good number, right? So that's why we are marking flag as 0 and we are breaking. Okay, I hope you get it. So overall time complexity will be like 500 into 500 into 10 into 2. So this is around order of 10 to the power 7. Okay, I hope you get it. The problem is quite interesting. The main part of the problem is how we can represent a string in a base 10 format. Sorry, a different base, and then the digit dp comes. So I enjoyed this problem, and I think it is a good D problem for Leetcode Weekly. If you have any doubt in any part of the code or expansion, you can always ask in the comment section. I will attach the code link in the description box. If you have liked the video, then please like, share, and subscribe to the channel.